We're now in the third section of our discussion of predicates and quantifiers, and we have a few exercises from our text to discuss, and then we will have completed this lecture. Exercise 3. Let Q of x, y denote the statement, the word x is the capital of y. What are the truth values of part A, Q of Denver, Colorado? And that's true. B, Q of Detroit, Michigan, false. C, Q of Massachusetts, Boston, and D, Q of New York, New York, false. Translate these statements into English where C of x is a comedian and F of x is funny, and the domain consists of all people. Part A, for all x the quantity C of x implies F of x. For every x, if x is a comedian, then x is funny, or every comedian is funny. For all x, the quantities C of x and F of x, every person is a funny comedian. Or for every x, x is a comedian and x is funny. C, there exists x, C of x, there exists x, the quantity C of x implies F of x. There exists a person such that if he or she is a comedian, then he or she is funny. There exists an x. If x is a comedian, then x is funny. And finally, part D, there exists x, C of x, and F of x. There exists an x, x is a comedian, and x is funny. There exists a funny comedian. 13. Determine the truth values of each of these statements and the domain, if the domain consists of all energies. For all n, n plus 1 greater than n. Subtracting n from both sides of the inequality, we find 1 greater than 0, which we know is always true. There exists n, 2n equal 3n. We need only find an integer that makes the predicate true for the statement to be true. Such an integer is 0. 2 times 0 is equal to 3 times 0, and both are equal to 0. There exists n equal minus n. We need only find an integer that makes the predicate true for this statement to be true. Such an integer is 0. 0 is equal to minus 0 is equal to 0. For all n, 3n is less than 4n. We need only find an integer that makes the predicate false for the statement to be false. The negative integers make the statement false. 3 times minus 1 is not less than or equal to 4 times minus 1. 27. Translate these statements into logical expressions in 3 different ways by varying the domain by using predicates with 1 or 2 variables. A student in your school has lived in Vietnam. Let y of x be x is in your school. Let v of x be x has lived in Vietnam. And let d of xy be person x has lived in country y. When the domain is just your schoolmates, we can write there exists x v of x. For one variable, and the domain is all people, there exists y of x and v of x. For 2 variables, the domain is all people, there exists x, y of x, and d of x Vietnam. There's a student in your school who cannot speak Hindi. Y of x is in your class, h of x is x, x can speak Hindi, and s of xy is person x can speak language y. When the domain is just your class, we can write there exists x, not h of x. When one variable, the domain is all people, there exists y of x and not h of x. And for 2 variables, the domain is all people, there exists y of x and not s of x, Hindi. A student in your school knows Java, Prolog, and C++. Predicate, y of x, x is in your school, j of x, x knows Java, p of x, x knows Prolog, c of x, x knows C++, and k of xy, person x knows programming language y. Domain. The domain is just your school. There exists x, j of x, and p of x, and c of x. One variable. The domain is all people. There exists x, y of x, and j of x, and p of x, and c of x. Two variables. The domain is all people. There exists x, y of x, and k of x Java, and k of x Prolog, and k of x C++. D, everyone in your class enjoys Thai food. Y of x, x is in your school. T of x, x enjoys Thai food. E of xy, person x enjoys food from country y. Domain, the domain is just your school. For all x, T of x. One variable, the domain is all people. For all x, y of x implies T of x. Two variables, the domain of all people. There exists x, y of x implies E of x Thai. And I don't think this should be a there exists, but a for all. And so we will change it and choose the for all. E, someone in your class does not play hockey. Y of x, x is in your school. H of x, x plays hockey. And P of xy, person x plays sport y. Domain, the domain is just your school. There exists x, not h of x. The domain is all people. There exists x, y of x, and not h of x. The domain is all people. There exists x, y of x, and not p of x hockey. And that concludes our lecture.